Hello, let us try to do this problem which was asked in CSIR Net December attempt of 2019. It is a fairly simple problem and all the concepts regarding this particular problem we have already covered. But before moving to this problem, let us revise a little bit of concepts. So the question asked is that a particle of mass m is confined to a box of unit length in one dimension. It is described with a wave function psi x is equal to root 8 by 5 sine pi x into 1 plus cos pi x and 0 outside the interval, the expectation value of the energy. So the problem is, it is a problem of one-dimensional infinite square well, where potential is given by Vx equal to 0 for all x lying between 0 and L is the length of the box, and outside it is given to be infinite. And we know that for this particular potential problem, the corresponding eigenstate I am writing it phi, are given by are simply given by root over 2 upon 1 sine of n pi x upon 1, okay, which amounts to writing root over 2 sine of n pi x. And what would be the energy eigenvalues? The corresponding energy eigenvalues would be n square pi square h cat square upon twice m a square, and length of the box is simply 1. So I'm simply going to write n square pi square h cat square upon twice m. Okay, now you see expectation value of energy, it is, if I want to find, it is always equals to summation Cn mod whole square into En. If my wave function is normalized, then I can use this particular formula. I have already derived this formula, and you know already that how to obtain this formula. It's very simple. That if I want to find the expectation value of energy, it is equals to what? It is equals to integration psi h cat psi. And I know that if my psi can be expressed as linear combination or superposition of wave eigenkets, because I know that this is true from the property of completeness of the wave function. Since I know that my wave function forms a complete set, so therefore psi can be expressed as summation Cn into phi n. And if I write the same, and if I use like double sums, because you see, if I don't use them, then I'll be making a mistake of duplicating it. So what I've done, I have written this particular, so sorry, it is psi star. I have written this as summation, this as Cm phi m star, and then h cat Cn phi n dx. I know this would be the expectation value of energy, and I know already that my wave functions, that eigen functions are also form orthonormal set. They also form what? Orthonormal set. So phi n star or phi m star into phi n dx, they are equal to 0 if m is not equal to n, and if m equals to n, then it is equals to 1. So from here itself, you know that this integral will be non-zero only if n equals to m, which gives us what? Which simply gives us Cm mod whole square. And h cat, when operated on phi n, would simply give us En, and integration phi m star phi n dx in the capacity m equal to n. This turns out to be unity. So I know that the expectation value of energy is simply summation Cn mod whole square times En. So all these requisite theory we have covered in infinite deep square well discussions. Now, let us begin with the problem. One of the best habits, two notes I'm writing before starting it. First thing is, always remember that whenever you are doing a problem, try to express the wave function as as superposition of, or as linear combination of eigenkets. This is something that I'm giving you a hint for your exam purpose. And also, whenever you are using this formula, that is expectation value of h is Cn mod whole square times En, then remember this formula is valid only when your wave function is normalized. So please remember that before using this formula, please ensure whether your wave function is normalized or not. Now let us come back to our problem. And the problem states that psi x is equals to root 8 upon 5 sin pi x into 1 plus cos pi x. So I'm going to very conveniently write this wave function here. So my wave function I can write it as root over 8 upon 5 sine pi x, and inside we have sine pi x into cos pi x. I'll simply write sine 2 pi x divided by 2. So what I'll get in terms of my eigenkets, I can write my wave function is nothing but the linear combination of state phi 1 and phi 2. Sorry. First, let me write sine pi x only, and then I'll do it. And I know already that my phi 1 is what? My phi 1 is simply root over 2 sine pi x. So in order to do that, I'm going to remove 2 root from here. So I'll simply get root over 2 upon root over 5. And then I can simply write as phi 1 plus 1 upon 2. And from here also I'm removing it. So I'll get root over 4 divided by root over 5 into root over 2 sine 2 pi x. So root over 2 sine 2 pi x is simply what? It is equals to phi 2. So I think this should be root over 2. Nahi. This should be, I think, simply 2. Okay, this because root over 4 is 2. So I have got root over, sorry, 2 upon root over 5, phi 1 plus 1 upon root over 5, phi 2. And this is clearly, this is clearly normalizable. This is clearly not normalizable, what I'm saying. It is the sum of Cn square, you can clearly see it is coming out to be equal to 1. Because C1 square is what? 4 upon 5, and C2 square is what? 1 upon 5. So the wave function is normalized. That's not a worry. So now we want to find the expectation value of energy. Expectation value of energy would be simply 4 upon 5 into energy corresponding to phi 1, that is pi square h ket square upon twice ma square, and this would be 1 upon 5 into the energy corresponding to this is 4 pi square h ket square upon twice m square. So effectively, I'm going to get what? I'm going to get simply 4 plus 4 is 8. So it is 8 pi square h ket square upon 10m. And that is equals to 4 pi square h ket square upon 5. So this is the required answer for your